By drawing the network and determining all the unique paths from start to finish will give you the project completion time, the critical path, and the critical activities. But that approach will not give you the actual start time and finish time for each individual activity. And that can be determined by using what are called forward pass and backward pass, or forward scheduling and backward scheduling. By performing forward scheduling, we can determine the earliest time when a given activity can start and finish. Now, working from the finish line and working backwards, we can find the latest finish time and start time for each activity. So we're going to look at these forward and backward paths now. We're going to use this convention. Okay, each circle is a node representing a given activity. The activity duration is given right below it. We'll use the upper half for the forward pass, and we will put the earliest start time here and the earliest finish time here. And working backwards, we will put the latest finish time here and the latest start time here. When we work on this on paper, we can put these values outside the nodes if the nodes are small and it's hard to write inside the circle. Now, forward pass. Now, I'm going to illustrate these rules in the example. So let's fast forward to the example. Now, this is the same network that we went over in the PowerPoint in a couple of videos back. So look at the network from that video. So here we start with activity A at the very beginning. Earliest start time is 0, and the earliest finish time is start time plus activity time. That's your finish time. Okay, now B also is at the beginning, parallel to A. So start time, earliest start time for B is 0, plus 3 gives you earliest finish time of 3. Now C comes right after A, only one predecessor, so only one arrow coming in. Then you just put the earliest finish time of A. That's when C can begin. So 2 plus 2 equal to 4. Now D comes after A and B. So you have to look at the finish time, earliest finish time of A and the earliest finish time of B. And the larger of the two will be the earliest start time for D. So 3 plus 4 equal to 7. Now similarly, we can work the rest of it. So F, only one arrow coming in. So 4 is the start time for F, plus 3 is 7. Only one arrow coming into E. So 4 plus 4 is 8. And here there are two arrows coming in. So you have to look at the two finish times and select the maximum between the two, which is 8 plus 5 is 13. And here again there are two arrows coming in. So 7 and 13, the maximum of the two is 13 plus 2 is 5. 13 plus 2 is 15. That's the finish time of H, and that is the project completion time. Next is backward pass. Okay, once again I'm going to illustrate these rules using the example. So let's fast forward to the network. Now remember, 15 is the project completion time. So we have to start with 15 and work backwards all the way to the start. So 15, then project completion time becomes the latest finish time for all the activities at the end. So 15 minus 2 is 13. Then go back. Now each node, we have to look at the arrows going out this time. Everything is backwards in the backward pass. So here there is only one arrow going out. The 13, the latest finish time, becomes the latest start time for F. Minus 3 is 10. Same here, only one arrow going out of G. So 13 is the latest finish time. Minus 5 is 8. And then E, you only one arrow going out. So the bottom number, the latest start time for G, is the latest finish time for E. 8 minus 4 is 4. Now for C, there are two arrows going out. So you have to look at the two latest start times for the two successors, and C must be done so that the latest time for each of these activities can be fulfilled, or the activities can start by the latest start time. So the smaller of the two, minimum of the two numbers 10 and 4, so 4 is the latest time by which C must be completed. 4 minus 2 is 2. Then D, there is only one arrow going out, so 8. 8 minus 4 is 4. Now B, only one arrow going out, so 4. 4 minus 3 is 1. Now A has two arrows going out, so you have to look at the two latest start times, and the minimum of the two is the latest finish time for A. 2 minus 2 is 0. And here there are two arrows going out, so the minimum between 1 and 0 is 0. So when we start with the project completion time and work backwards, at the end we must go back to 0. We can find the slack by finding the difference between the two finish times or the two start times. So let's look at that. So slack is LS minus ES, or it is LF minus EF. Both will be the same number. So we have the earliest start and finish times, the latest start and finish times. So subtract the two finish times or the two start times, so you'll get the slack. And when slack is 0, then that is critical, and it will be on a critical path. The slack is positive, then those are the amount of cushion we have. If there is a delay, that much delay can be tolerated. Now remember, slack can never be negative. If you come up with a negative slack, that means you made a mistake somewhere. So here is the critical path. And we can construct Gantt chart based on the earliest start and finish times. So each bar represents the start and the finish time. Or it can be latest start and latest finish times. The latest start and finish time Gantt chart will be slightly shifted to the right.